Hey, fellow mathers, before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam Harris.
And I'm Kim Montague.
And you found a place where math is not about memorizing and mimicking, where you're waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can actually mentor students to think and reason like mathematicians did when they were young. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be. Hey, Kim.
Hi. I'm totally going to tell on you because, yeah.
Okay, fine.
We
bring it on.
Yeah. So Pam and I have lots and lots of meetings for different kinds of projects.
Oh, and, gosh. Yes.
When it's just the two of us, sometimes we meet on Slack. We huddle, so no video.
You're going to tell them this?
I totally am, yeah. And sometimes, kind of back in the day, we just would get on the phone and pace our house and talk. And, sometimes when there's a group of us or maybe you just want to see each other's faces, we get on Zoom. And so it's typical when we're going to start a meeting, Pam or I will text each other and say, how do you want to meet? And she sent me a text this morning and said, how do you want to do Slack or Zoom or text phone. Or whatever phone?
Yep.
And I wrote back Zencaster because she had clearly forgotten that we were recording a podcast today. And she was like, oh, shoot, right.
Call me out. Yep. It's true. To be clear, we normally, when we do our calendars, we normally will put in the calendar invite what we're doing. And we switched to today, right?
Yeah,
it was supposed to be a typical meeting and today we're recording. So that's my excuse.
I totally laugh.
Fine.
Actually, I have another story for you. We'll get to some math in a minute. But
this is what happens when you and I spend a week together at NCTM and NCSM, huh?
I know. Okay, so I have to tell you, you're going to appreciate this.
Okay.
And it's really about why I stand by pencil over pen. So it's appropriate. No, I'm not even joking. All right,
bring it on. Because I'm holding a pen in my hand right now.
Well, you're not going to want after this. So last night or yesterday after school, Cooper came home and he was super excited because he had been asked to wear his uniform, his scout uniform, and be in a program and do flags. And he was super excited about it because he loves doing flag type things and the, ceremonial, whatever. So he's super excited. And it was kind of like 7:30, 8:30 when he told me. And I said, cool, go get your shirt and bring it to me and I'll iron it so that it really looks sharp. And so we went and got it and he brought it in. And he had just recently gone to some other event where he wore the shirt for 30 minutes. And so he just took it off and hung it up. He brought me the shirt and he held it out to me. And I was like, what is that?
Oh, no.
Uh-huh.
Is it a pen leak?
All over the stinking shirt. Big blobs of it. And he looked at me and his eyes got really big and he literally started panicking and getting upset. And I was like, bro, hang on. Let me see what I can do. But I knew. Everywhere. There's splashes everywhere. And he was like, did I do that? And he had a tiny pen in his pocket and the pen was off. It just had leaked everywhere.
Stupid pen.
So anyway, I, did all the things, Googled the things, hairspray and alcohol and sanitizer and blot it and wash it and all the things for hours. So today's podcast is brought to you by 3 hours of sleep.
Oh
And
no.
and thank goodness for friends who bailed me out because that shirt's in the trash. Horrible. Pencils are way better. Stupid pens. Hate them.
Gosh. Kim, that's horrible. I'm so sorry. So like
Ugh.
you have a friend that like is loaning you a shirt? Is that
Well,
like what
so I actually live in a neighborhood with a couple of our scout moms, and recently a kid had grown it out of one, and
Oh,
the other
brilliant.
mom is the advancement chair who holds all the patches, and so
Oh, God.
they knew that I was struggling, and one of them showed up last night with a shirt from one house and patches from another house, and I don't know how to sew, so they're all taped on. Whatever, hope they stay. It's horrible.
Okay. All right. You got me there.
Yeah.
That's a pretty,
Stupid pen.
okay. There's the pen and
Mhm,
pencil
mhm.
argument continues on. Sorry
All right,
about
we should
that.
start. Sorry.
Bam. All right, Kim. Hey,
Okay.
let's have a podcast
Yeah.
about math being figure outable.
Well, one more side note, but we got a review. I'm loving the reviews. They made me so happy. And
That's
so
been really fun to get
I
so many
know.
reviews. Y'all, thank you for sending the reviews.
Yeah.
Keep, I don't know if you know this, but if you put in a review and like or what do you call it when you rate the
Hmm.
podcast, it actually gets shown to more people.
Yeah.
So we appreciate that because our goal here, we don't monetize this podcast, right?
Hmm.
We just do it because we actually want to change the way
Yeah.
math is viewed in the world. And so this would be helpful, if you don't mind giving us a rating and a review. So, all right, Kim, you got a good one
It's
today?
super fun to hear people's stories too. Yeah.
Oh, it
So
is. Yeah.
J Poor, the title is Completely Changed My Way of Thinking, which is
Ooh.
super fun. And it says, I have listened to every episode and I learned something new every time. Thank you for sharing and making math more figure outable. My brain and subsequently my students' brains are getting this is required to truly understand math. So maybe acquired. Amazing. So thank you.
No, I think he means are getting required. He are getting
Getting
required to truly understand math. Like in other
okay.
words,
Yeah.
in class, we're not getting away with just mimicking. We're actually like requiring they understand it, and
Yeah.
that's amazing. Yeah. Oh, nice.
I
Thanks,
know.
Jay Poor. That's super cool.
All right,
Oh,
finally moving on. We
all
are
right, all right.
marching into December this week. Can you believe it? It's
Yes,
super
it's my
hard to
favorite
believe.
time of the
I
year.
know. Well, it's
It's the
big holidays
most
for you.
wonderful time. Oh, I
So
love it.
we
Love it.
we have saved a very big topic to round out the year.
Oh yeah, this is gonna be fun.
Yeah, it's been asked for. You can search the Math is Figure Outable teacher group. You should join us. But it's come up
Join
a
us there. Yeah,
bunch of times.
people are
Um,
asking about it all over the
mhm,
place.
mhm. I also met some ladies, I forgot to tell you this, at NCTM. Shout out to Edna and Felicia. And they asked for this as well. And I said, oh,
Hey,
you never know.
all
So
right.
today we are starting a short series on integers.
All right, so Edna and Felicia and the Math is Figure Outable teacher group and anyone else who's ever asked for integer work, let's dive in and do some stuff with integers. Yeah, Kim, I'll also admit, that's not the right word. I will inform, I will tell, I will say that often when I work with middle school teachers, they'll sort of kind of go with me. They're like, yeah, this is all making sense. Yep,
Mhm.
yeah, but what about integers? And I'm like, what about integers? And one of the very first times that teachers pushed back on me, so this is several years ago, middle school teachers I was working with. This was early in my days. I kind of had gotten a pretty good handle on whole number numeracy. I hadn't really done a lot of higher math yet, so several years ago. And they were like, "What about integers?" And I thought to myself, "Well, no, like you just kind of keep thinking about
Mhm.
integers." And they're like, "No, everything changes when you get to integers." So I did some little action research I wanted to mention to you today, where I pulled in. So this is when I was working really heavily with you and the other teachers at my kids' elementary school. I was doing a lot of the professional learning K-5 in the whole district. And so there were kids who, my kids' friends and kids in the neighborhood, who were getting real math every year. And they had
Mhm.
had real math now for several years. And I grabbed 3 or 4 fifth grade kids in the neighborhood and I said, "Hey, like I'll give you some cookies or whatever, but come here, do some math with me." And they were like, "No
Mhm.
problem." I mean, we had fun. They knew it was a good thing. And so I sat them down and I said, "Hey, like if I just gave you the problem, well, first of all, we talked a little bit. I was like, what does negative 25 mean?" And they were like, "Well, it's like on this side of the number line and it's kind of like you're in debt." And they had some decent things to say about what negative numbers mean. And so I just said something like, so like if I had, I don't know, 10 plus negative 25. Like, what does that mean? And they said, well, yeah, it's, you're at 10 and then you would sort of jump back 25. And I'm actually just putting that on it just because I keep track of my thinking. So if I'm at 10 and jump back 25, they were like, well, you'd hit the zero, you got 10, you'd hit the zero. Then you'd have to go 15 more to get the 25. So now you're back 15. And so it's negative 15. And I said, so like, have you done this? Like, they're like, well, no, we're fifth graders. We haven't done any. And I was like, okay, cool. So like, what if, and I just threw a couple of problems at them and they just kept reasoning the way they had been reasoning about whole numbers. And I found that fascinating. So first thing I would say to you is there is some sense in getting kids, to think and reason with whole numbers, actually think and reason using relationships, using a number line to represent their thinking, and it becomes a tool for them to think with. Then we need to help integers mean something. And so today, let's spend some time, Kim, on discussing what that means. When I say, what do integers mean? How can we do that with kids? So you up for that?
Sure. Yeah.
All right, cool. So I think you're going to love this first one. I think one of the best things that we can do to help get kids to really understand the meaning of integers is play games.
Yeah.
Oh, there's some.
I love games.
You do love games. That's why I knew you'd like that one. I do still. I think you and your family play more games than me and my family, which
It's
makes me
because my kids love
sad.
games.
Actually, well, my kids like them enough, but yeah, I'm gonna start pushing it more. We've played plenty of games, but I hear you and I'm like, they play more games. So I don't know if it's the competitive streak in me or what it is, but we're gonna be playing. I now have a couple daughters-in-law who really like to play games. That helps. Anyway, so games. So let's what are I'll just throw to you. Do you have any games that deal with negative numbers?
Oh yeah, actually one of our favorites.
I had a feeling. Yeah.
Yeah, we play this game called Sky Joe.
Okay, tell me about it.
And it's a card game where you lay out three 3x3, 4x3 grid of cards. You face them upside down.
Okay.
So you can't see the numbers, and you basically are exchanging or trading cards based on
what's on the cards?
Sorry, numbers from -2 to 12, and you want the lowest score. So you draw a card, you decide where you want to put it. You can't look at the card first. You're just kind of exchanging. So
you want the lowest score. Sorry, I'm catching up. Yep. Okay.
It's a little bit of a luck of a draw thing where you hope you get the lowest card drawn, but then you have to like kind of memorize where things are, and you have some strategy.
Kind of a memory kind of thing.
Well, then there's strategy because if you get 3 of the same number, then the whole row goes away. So even if you get 3 12s in a row, the score goes away. And so my kids are super big into taking a chance on that. Anyway, but because there's negatives, then and you want to get the lowest score, then when you total your score, you're going below 0 a lot of the times.
And I wonder when you're totaling your score, if you ever say, well, I've got a 5 and I've got a -5.
Yes.
Yeah. So you might look for nice combinations that sum out to 0, and then you can kind of go from there. Yeah. That's an excellent example of something that could get kids kind of thinking about negatives. Like if even playing Monopoly, I think that you can't go in the hole, right? You can't go in debt. What does it mean to be in debt? Oh, go ahead.
Sorry. Yeah. You made me think of a game that we have that you can, which is interesting. So we have this game called Payday. It's pretty much younger, but you basically follow a calendar and bills happen to you and this and that and the other. You get paid. We used to play it younger, but in that, if you can't pay your bills, then you borrow from the bank. And so then you keep a total of your running. You have to pay the bank back plus interest. So
keep track of that debt. Yeah.
Hopefully you don't get too many bills and you live in negative for too long.
Yeah. Yeah. Let's all not be in debt. That's a good thing. I know, teachers. I know you're like screaming at your radio right now. Radio? How old am I? Oh my heavens. Did I sleep last night? You're listening to your podcast wherever podcast player, whatever that is. And you're screaming. You're like, Pam, don't you know we're teachers? We don't make any money. I know. We're both teachers too. So we get it, but golly, in fact, who's Mike? Mike, what's your last name? It'll come to me in a minute. Good friend of mine in teachers teaching with technology. Mike does a really good presentation about debt and helping teachers really think about staying out of debt. Anyway, Mike, sorry, I can't remember your last name. Good guy. Anyway, there's another game that we like to play with younger kids where we don't necessarily have integers involved, but then you can bring integers in, and it's called Close to 100.
Mm-hmm.
I've heard it called Target 100, Close to 100. I don't know, I can't think of any other names, but there's lots of versions of it out there where basically you've got digit cards, so cards that have the digits on them, and you draw 6 cards, and your goal is to choose 4 of them to turn into 2 digit numbers to sum to get as close as you can to 100. So, say you get 45 and 67, you add those together, and that's going to be a little over. And so then, so when you originally play it, if you go a little over, then your score is how far you went over. So, say you were a sum of 102, then you would have a score of 2. Let's say that your sum was 97, then you would have a score of 3. Well, for young kids, you just sort of play where the scores, no matter if you're over or under, the scores are positive. But pretty soon you have students, even super young, that will go, well, wait a minute, if we're over, is that like negative? Like, like Price is Right? And so, if your sum is 102, is your score -2?
Mm-hmm.
Or vice versa. If you're under, is that negative? And so there's this brilliant kind of distance from 100 that comes out, and you can
Mm-hmm.
kind of think about it as the absolute value, as just the positive distance, but you can also bring in negatives. And then you've got kids that try to get a little bit of a higher score in one round because they're already in the hole, like their score is negative, and so they're trying to get a positive to kind of zero it out. And all of those kind of zero pair ideas are brilliant that can come out in a game like Close to 100.
Yeah, so good.
All right, cool. So another thing, so games are a great way that we can kind of get kids to think about this idea of negatives and positives and how they work together, especially as you're summing scores. Another thing that can be really nice to help kids think about the meaning of integers are versions of clothesline math. So clothesline math, we really like. Chris Shore and the clothesline math site does a really nice job of talking about different things to do. Well, one thing that you can do is just give kids in order a set of numbers. And so you can say things like, all right, here's you put the clothesline up and you just say, so Kim, we'll do that. If I had a clothesline, I've kind of drawn a line on my paper and I were to say, hey, Kim, where are you going to put 0? And you would just choose where you're going to hang this
Yeah.
card on that line. Yeah. Where would you put it if the line was kind of hanging there? Describe where you'd throw it.
I put it in the middle, actually.
Yeah. And a lot of kids usually do that.
Yep.
Though the younger they are, they put it on the left-hand side.
Sure. Yep.
Right. But, we're talking about integers today. So you're like, there might be some things happening
Mm-hmm.
on both sides. And then I might say, where's 6? And then you would
To the right.
to the right, and then you're gonna have to like decide how far to the right. You might put it all the way to the right somewhere, but we stuck it somewhere. And then I'll say, where's -6?
Mm-hmm.
And then where would you put -6?
To the left of the 0, the same distance as 0 to 6.
And that's kind of important. And so then we talk about how, so the distance is the same, but one's on one side of the number line, the other one's on the other side of the number line. And then I might like say, where's 10? And then, if you had put 6 all the way to the right, then you're going to have to adjust 6 because now we have to fit 10 on there.
Mm-hmm.
So you'd stick 10 on there. And then I might say, where's -10? But then I also might start with where's -2.5?
Right.
And we don't have the positive 2.5, but I might say, did anybody use the positive 2.5 to help them think about -2.5? Or can you, once you have one, could you have the other? That one doesn't last all that long unless you just start like throwing a bunch of rational number stuff in there as well. So, where's 2/3? So they have to like think about if 6 is there, they're like, well, can we put 1 up? That would help us think about where 2/3 is. And you can say, okay, cool. Where's -2/3? So just, kind of throwing in some, you can't do just positive and negative numbers too long. That gets a little boring. So then you can kind of throw some rescaling in there. And, like I said, where you had the 6 and you had to shift it because now we have the 10. Or now you have the 6 and then I say 2/3 and you're like, whoa, 6 better be much farther over there if we're going to be able to fit 2/3 in here.
Yeah.
And then the negatives and positives. Go ahead.
Yeah, I think it's really important that you do that work though, because kids are so used to the number digit increasing as you go to the right.
Mm-hmm.
And so, sometimes I've seen plenty of students who, when you put -6 and then you go to put -7, like it's a little bit of a mind twist for them to think, where is it bigger? Is it smaller? Which way is it going compared to the -6?
And that's a whole conversation about why -7 just went to the left of -6. Not like, doesn't it usually go 6, 7? I'm glad you brought that up. Yeah, we're nicely done. And sometimes then we can draw kind of result that they had with clothesline math on the board. And we can say, so on my paper right now, I have 0 in the middle, I have -6, a distance to the left, I have +6, a distance to the right. And I actually have drawn kind of a jump from -6 to 0, and I have 6 above it, and then a jump from 0 to 6, and I have 6 above it. And there's this idea of that the distance is the same.
Mm-hmm.
And I might kind of even fill that in where I have like -5, and I have a smaller jump that's 5, and 5 that has a smaller jump that's 5. And we kind of have these sort of rainbow things kind of happening,
Mm-hmm.
all stemming from 0. And that we can really think about the distance from 0. And so the negative and positive has everything to do with which side of the number line it's on. And then, like you said, the kind of order things go is a little mind trippy, and we
Mm-hmm.
give kids experience with that. With clothesline math can be a really nice way to go. Cool. Some things that come out of that, kids are talking about absolute value. They're talking about distance. There's this idea of kind of reflection. If I can find the one, then I can kind of reflect it over 0. It's a nice geometry thing that's going to come up with transformations. So we kind of have this reflection idea coming out. Nice things that can come out with clothesline math. Anything else you can think about there, Kim?
No, I think you got it all.
All right, cool. I just, always want to give, just because I can't think of any more doesn't mean I shouldn't let, I often do that with students, right? I'll say, hey, I can think of 3 ways.
Yeah, I love that you do that.
Well,
I
thanks,
do.
thanks,
I think
Dr.
that's a
Harvey
really-
Fletcher, because he's the one
Okay.
that started it at BYU. He's the one that would say, I can think of solving that in 4 ways, and then he would
Yeah.
do it in 3.
Yeah,
Like, what? Yeah.
that's great.
I asked him once, he goes, well, why would I ever say the number I can think of? Because I would never want to limit your thinking. Yeah, so thanks, Dr. Harvey Fletcher. I don't think he's still around, because he was older when I was his student at BYU. Anyway, moving on. Another super important thing that I'm going to suggest in making meaning out of integers. Well, in fact, maybe I'll just say one other quick thing. In the standards in the state of Texas, I'm clear, and this might be true for other states. I'm just really clear because I did a lot of work with teachers around this in Texas, that it used to be, so is it still? See, this was a while ago, but it was that 6th grade was the place where it just said meaning of integers. And then it wasn't until 7th grade where the students were supposed to operate on integers.
Mhm.
And 6th grade teachers would say to me, I don't know what to do here. So for anyone whose standard says help students understand integers, this is what we're doing today in today's episode. And so one of the most important things that you can do to help understand integers is to use contexts.
Mhm.
And I think there's 3, maybe 3.5, a fourth. I'll throw a 4th one in there that's okay to help students think about what integers mean. And here are my favorite 4: temperature, elevation, debt, and American football.
Mhm.
American football is the one that's a little like, okay. I like to use American football if students are familiar with the game. I don't want to have to spend a lot of time getting them, like what does it mean to have 4 downs? And because we're going to use the line of scrimmage as kind of our 0 line. So it's very important. You're not using the yard lines on the field. It's not where the 0-yard line is, or the 50. You're using the line of scrimmage as kind of the 0. So if you have to do too much explanation for American football, then it's kind of not worth it.
Yeah.
But if you have a lot of middle school boys that you're trying to bring in and they've got football down, bam, like football can be a great way for them to go. They've already thought about a lot of integer stuff with football, and you're just kind of bringing it to the surface, making it more kind of, I don't know, concrete's not the right word, but kind of abstracting out ideas that they've kind of been playing with so that they can like, oh yeah, that makes sense. There are some advantages and disadvantages to those. So I just mentioned a disadvantage to American football. If kids don't know very much, then don't, maybe, but it's an advantage if they know it. What about debt? Well, an advantages to debt is we would really like kids to know about debt and to not get in it. Our
Right.
country's debt's terrible. Financial literacy would be a great thing to bring in. So that's super good. But debt gets really weird with subtraction, because how do you subtract a debt? So that's kind of weird. Elevation is, I think, phenomenal. And I think we should use it with kids. You might have to do a little bit of description about what it means to be above and below sea level. If kids kind of live at sea level, it's maybe a little bit easier to talk about elevation. I grew up at 4,000 feet above sea level, so it was a little bit weird to talk about the 0. I couldn't even almost kind of picture it unless I'd been to the ocean, where it was kind of at sea level. But I think you could talk about that, and I think you can kind of get that down. So where you live is maybe a pro or con. And then the same with temperature. If when we lived in Michigan and Idaho, I could talk about above and below zero,
Sure.
especially Michigan. Oh my, Kim,
It's cold.
it was so cold in
Yeah.
the winter in Michigan. We were below zero a lot. So if you live here in Texas, it's almost weird to talk about below zero because
Yeah.
it's so rare. I don't even know if it ever gets below zero in Central Texas where we live. It gets below freezing. So if you're in a Celsius, then that makes sense, but it doesn't get below zero. Anyway,
Right.
so
Right.
so you might have to describe those kind of contexts to help it make a little bit more sense. But I think these 4 contexts can be super helpful. You're like, Pam, what do you do with those contexts? Well, y'all, what do I always do with math? Let's do a problem string. All right, Kim.
Yep.
Let's talk temperature. If it is 11 degrees, brr, we could talk a little bit about how cold that is. Be a human, get a little brr, it's cold, 11 degrees. And it raises 2 degrees. How cold is it?
Still cold.
Talk to me. Go ahead.
It is, it's increased 2 degrees. So now you're at 13 degrees.
So as Kim says that in a class full of 6th graders, I'm going to say, so Kim, you're at negative 11. I've just drawn a vertical number line.
Did you say negative 11?
I said negative 11.
Oh, I thought you said 11 degrees.
Oh, my bad. Negative 11 degrees.
Sorry. That's totally different.
Well, is it?
I mean, if it's negative 11 and it raises 2 degrees, then I'm at negative 9.
Ah, okay. Well, I'm not sure I heard you say anything, so if I did, I was ignoring you.
It's negative 9.
Okay, so as you're saying that, I've drawn a vertical number line. And a tick mark, I've put negative 11. And then you just said raise 2 degrees, so I've kind of gone up 2 degrees. And where is that? And you're saying it's at negative 9. Yes?
Yep.
And that, I might say to kids, so where's 0? And I might throw a 0 on there, but I might not. Yeah, okay, cool. But then, importantly, next to that, I'm going to write, or maybe I usually write problem strings, the problem to the left. So I'm going to write negative 11 plus 2. And you're saying that is negative 9. So now I have the sentence, negative 11 plus 2 equals negative 9. Next problem. Hey, Kim, what if it's 18 degrees? Still cold, but not too bad. 18 degrees, there's a big storm and it falls. The temperature falls 21 degrees. Where are we?
So I drew a number line, also vertical, and I dropped 18 degrees to get to 0. And then I dropped 3 more degrees to get the negative 21, or the dropping 21.
Okay, so you started at 18, dropped 18 to get to 0. Yep. And then how much more?
I dropped 3 more.
Why 3 more?
Because I dropped 21 degrees.
Because you dropped 18, now you've dropped 3 more. And so now you've dropped your 21. Where did you land when you dropped that 3 more?
Negative 3.
At negative 3. So then I would write on the board 18.
Yep.
I have to remember what the numbers were. 18 minus 21 is negative 3.
Yep.
Cool. Next problem. How about, I'm going to take my glasses off. That's why I'm having a hard time. I can't see. Anybody? Don't
I
get
put
old.
glasses on to see.
Don't I know we're different that way. Okay. So what about you've got $20.
Yep.
And you told a friend that you would give them $32.
Oh, liar. Okay, so I'm going to give them the 20 I have because I'm super nice. But then I wish I had 12 more. I'm in debt. I'm in debt $12.
You're in debt $12. And so I would now, I'm going to go a horizontal number line on this one.
Oh, I did too.
Okay, I'm going to start at the 20. Back up that 20 to get to the 0. Back up 12 more, which you've got to go find somewhere. So you're landing at negative 12 because you're in debt 12 degrees. Cool. Next. Hey, let me just say, in the midst of this string, y'all, I'm doing this in the grade that says understand integers. I am not pretending right now I'm getting kids good at operations. Right. I'm really just investigating integers. Where are they? What does it mean when we increase and decrease? Next problem.
But hang on a second, because
yeah,
you write the equation on the board, and this is very much reminding me of even when we work with very young students, when they say, this is what I did, you and I will record, quote unquote, what they did with parentheses and really demonstrating the properties. And people will say, oh, they're too young for that. Well, not if it's coming from them and we're just showing them what it could look like. Yeah. When your brain does that, it could look like this. Yep. Absolutely. And to be clear, we're doing it both on a number line in a very nice visual model and with equations so that we're connecting those, the scenario, the context with the model, the open number line with the model of equations. Yeah, nice. Thanks for bringing that up. Yep. Next problem. Hey, Kim, you're in debt $5.
Now, at this point in the problem string, I'm going to actually start writing the equation. Maybe, kind of depends. In this podcast, I feel like I would. With kids, I might wait a little bit longer. I might just say the scenario, represent it on a number line, and then write the equation. I'm going to do that for a long time.
Mm-hmm.
But I guess I have in my head, I'm working with adults. So at that point, I would have written, you're in debt 5, so I've written -5, -5.
Mm-hmm.
And then you spent $15 more. So then I might write, you spent add, but then.
And you spent, yeah.
Yeah, -15. So right now on my paper, I've got -5 plus -15. Where are you?
-20.
Because?
Because I was 5 in debt, and then I jumped back -15 to get to -20.
And when you say jump back -15, that's you kind of
I
meant you
jumped
jumped back
back
15,
yeah.
or
Yep.
you subtracted 15, either one.
Yep.
And so that's -20. And as you said that, I drew that on, like, literally, I drew, as you said, I started at -5, jumped 15, and landed on -20. Cool.
Yep.
Next problem. How about if you're 6 feet above sea level?
Okay.
I've just written a 6, and you fell 12 feet, -12.
Oh, I don't think I fell. I think I dove.
Okay.
I hit the water.
You don't fall. Okay. All
I
right.
mean, if I'm 6 feet above, I'm like on a cliff.
Got it.
Little tiny cliff. Yeah, I'm at -6.
You're at -6 because?
Because when I went down 6, then I was at 0. So I hit the water, and then I went down 6 more to get to -6.
Cool. And I actually put that on a vertical number line. Started at +6, dropped down 6 to get to 0, dropped down to -6, landed on -6.
Does yours have a little person on the edge?
It does not.
Mine does.
You're hilarious. Okay, what if you started 11 feet below sea level and you walked up 3 feet?
I started at 11, -11, and then I went up 3, so now I'm at -8.
So I've written -11 plus 3 equals -8. Yeah?
Mm-hmm.
Okay, lastly, what if it is American football?
Mm-hmm.
And from the line of scrimmage,
Mm-hmm.
the first play you gained 2 yards, but then you were pushed back 7 yards. Where are you with respect to the line of scrimmage?
So if I made 2 yards, then I kind of was at the 0 and I jumped forward 2. So I'm at the 2. But then I got pushed back 7. So I got pushed back to the 2. So I'm back at 0. But I got pushed back 3 more. So I'm at, wait, you said 7? So I got pushed back 5 more. And now I'm at -5.
Because 5 back from 0 is -5. Nice. So get it together, team, because you're 5 yards behind the line of scrimmage. You've got to get how much. In fact, this is I wasn't even planning to ask this, but if you're 5 yards behind the line of scrimmage, how far do you need to go to get the next down? Now I'm testing Kim's knowledge of American football.
Do you have to go 15?
Why do you think so?
Because I know you have to go 10 in a play, but it doesn't count if you got pushed back. You still gotta go more.
Yeah, kind of. Yeah, so you got to get that. You got to make up the 5 to get to the 0, and you have to get 10 from that 0. So it's not 10 in a play, but it's 10 from the 0. So you have four chances to get the 10 yards. But you're right. Since you were back, you got to make up the extra. Yeah, nice. So all of that is like negatives, positives, and stuff. Let's just do one more quick one. So what if I said, hey, you got sacked. You know what? Actually, yeah. You got sacked, and you're behind the line of scrimmage 5 yards.
Okay.
And then, crud, you got pushed back 3 more.
God.
I know.
So I'm at -5. I got pushed back 3. So now I'm at -8.
You're at -8. So, y'all, all of that are ways, all of those kinds of problems. Notice we used temperature. We used money and debt. We used elevation, and we used American football from the line of scrimmage. Those are all ways of getting kids just to understand what's happening when you are adding and subtracting negative numbers, but really, like, also where positive and negative numbers even are. And so when they do it, when they're actually thinking about what's happening in the context, then we write, we represent their thinking with number lines, and we also represent their thinking with equations. And then we can get a little bit more crazy, hey, perhaps in our next episode. All right, so major takeaways from today: use context. Play with negatives when they come up in real life and games, and represent thinking on number lines and with equations. Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figure-outable. Thank you for listening and making math more figure-outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure-outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.